Once we've defined what a prime number is, we can start doing something like this. It's called a prime factorization. A prime factorization is writing a number as a product of a bunch of prime numbers. So for instance, 24, one way to do this is what's called a factor tree, and you just break the 24 up as a product of lesser numbers until you can't go any further. So 2 times 12, for instance, 12 is 4 times 3, and 4 is 2 times 2. Each time I do this, I look to see if I can keep going on each of these. So 2 is prime, so that's as far as I can go there. 3 is prime, and each of those 2's is also prime. Looking through, I go to all my, wherever these terminate, these are called leaves of the tree, and necessarily all of these have to be prime numbers. And if I kind of look at all of them together, then 24 is equal to 2 times 2 times 2 times 3. So well, there's 1, 2, 3 2's, and then a 3. 1, 2, 3 2's, and a 3. That's one way to write out the prime factorization. I'm not the biggest fan of doing a factor tree all the time, because it takes up a bunch of extra space on the paper. Instead, what I like to do is I like to go through my list of primes. I'm going to list out the first few of them here. 2, 3, 5, 7, 11. That's good enough for now. And when I'm going to write this down, what I do is I just check these primes individually. 2 is a factor of 24. So what I'm going to do is I'll write down the 2, and then I'll think, okay, whatever is going to be left here, it's going to be a 12. Now I'm just going to factor 12. Because it's a very similar process as to what I'm doing over with the factor tree, only I'm figuring out a way to write it in line. Next up, I'm going to test my 2 again to see if the 2 is a factor of 12, and it is. We get 2 times 6. Whatever is in here is going to be 6. Alright, well, actually, I don't need these parentheses. Whatever is going to be left over, this was 12. I'll cross that out, and this right here is going to be a 6. Alright. Oops, no, I had that backwards. No, that's right. And then 6, of course, is 2 times 3. I could do that again. So this gives me a nice way. Usually I don't write it down like that. Usually I just store it in the calculator. So in the calculator, when I divide out a 2, I have a 12 stored in the calculator, and then I do it again. I divide out another 2, write that one down, and then I have a 6 stored in the calculator. And then I happen to see 6 is just 2 times 3, so I write that down. It's a good idea to, whether you're doing it this way or this way, to plug this bit back into the calculator and make sure it actually does work out. So 2 times 2 times 2 times 3. It's easy enough to type into the calculator and make sure that you got your prime factorization correct, that the product of those numbers actually is 24. Alright, if I want to do the prime factorization of 40, what I would do is I would say, okay, I'm going to do the same sort of thing. I'm going to first start off 40 equals 2 times, well, I'm starting off, sorry, I skipped a step there. 40 is even. I see that 2 is a factor of it, and so I write down my 2. On my calculator, I can do 40 divided by 2. Now I'm thinking about a 20. Now I'm just trying to find the prime factorization of 20. Well, that's not bad. That's 2 is still a factor of that, so I'll go ahead and write down a 2. And now, divide that 2 out since I wrote it down. I have a 10. Now I happen to recognize 10 as 2 times 5, or you could do it a third time and, do it that way. But 40, we get 2 times 2 times 2 times 5. And again, since we figured out that prime factorization, whenever you do several steps, it's a good idea to kind of check your work, and you can see that does actually equal 40. Now, the least common multiple. This is the first real use of the prime factorization that we're going to see. It's called the least common multiple. And how this works is we're going to take the prime factorization of each of these numbers. 24 is equal to 2 times 2 times 2 times 3, and 40 is equal to 2 times 2 times 2 times 5. Well, the least common multiple, it needs to have all of these, it needs to have any, well, I guess, yeah, all of these factors. The factors that I have here have to also be factors of what's called the least common multiple. Multiples are going the other way. When I say that 2 is a factor of 24, then I could flip it around and say 24 is a multiple of 2. And if we're looking at 24 and 40, if we're trying to find the least common multiple, kind of expressing what this is, I could start off by listing out 24, and then 2 times 24 is 48, and then I have a 96, and then, you know, I could start listing out all the multiples of 24, and then similarly doing all the multiples of 40. 40, 80, 120, and so on, and I could go until I get one that's in common between the two of them. But this could be potentially a very long process before I get one that actually overlaps. So instead what we do is we look at the prime factorizations, and I say, well, if I have something that's a multiple of 24, that means it can be written as 24 times something else. So 24 is 2 times 2 times 2 times 3, and it's going to be most likely times something else. If it's a multiple of 24, it has to have all of this stuff as factors. And, well, if it's a multiple of 40, it has to have 2 times 2 times 2 times 5. Well, 2 times 2 times 2 times 5 is already present. And, well, sorry, 2 times 2 times 2 is already present. I just need to tack on a 5 on there. And you can see this number, this is 40 times 3. So this stuff right here is my 40. And then I have a 3 there. I know it's 24, because that stuff right there is 24. It's 24 times 5. And actually, I guess it was this. If I multiply these all together, 2 times 2 times 2 times 3 times 5, you can see I get 120. So it actually would have been the next number in that list. This is the, in my opinion, the easiest way to find the least common multiple of two numbers. You look at their prime factorizations. So let's do another example. The LCM of, let's do the LCM of 75 and 30. So first off, I'm going to figure out what each of their prime factorizations are. So 2, 3, 5, 7, 11, 13, and so on. That's my list of prime numbers, just kind of on the side there so I can refer to it. So to find the prime factorization of 75, I'll look through my list. 2 is not a factor of 75, so I'll move on to the next one. 3, I'm not sure right off the bat, but maybe it is. Let's see. 75 divided by 3, you can see it actually does come out as 25, and that makes sense. If you have 3 quarters, 3 25-cent pieces, we have 75 cents. So we get 3 times 25. Oops, I'm not going to write down the 25, though. I'm just remembering it. And at this point, let's say you don't happen to notice that 25 is 5 times 5. You're just checking your primes. Well, we've already ruled out 2's. We would just need to continue checking 3's. We would say, okay, is 3 a factor of 25? Well, 25 divided by 3, of course, doesn't come out, but 25 divided by 5 does. So we get 75 is 5 times 5, or 3 times 5 times 5. 30, let's see, I'll start this process again. It's 2 times 15. 30 divided by 2 is 15. Now I'm trying to factor 15, and 2 is not a factor of 15, so I'll move on to the 3. Well, 15 is 3 times 5. So here's my 75 and my 30, and I'm looking for the least common multiple of these two numbers. So the least common multiple, I'll just write down my first number, 2 times 5 times 5, because no matter what, it has to be, what our least common multiple has to have all of this stuff. So you could just start there. There's other ways of going about this too, but this is the way I'm going to do it right now. So we have 3 times 5 times 5. Okay, so we're probably going to have other stuff, but we've guaranteed that this, whatever number is here, is going to be a multiple of 75. Now let's look at the 30. It says we need to have a 2. We don't have any 2's though, so I'll go ahead and write a 2 down. It says we need a 3. We have a 3. It says we need a 5. Well, we have a 5. Well, we actually have 2 5's. That's plenty. And so this right here would actually be enough to be able to, we could either, we could write it, this 75, this is 3 times 5 times 5 times 2. We could write it that way. This is 75 times 2. Just showing that this is, whatever number we get here is going to be a multiple of 75. I could also show that it's going to be a multiple of 30. So 2 times 3 times 5 is 30. And the only thing that's left over there is a 5. So this is 30 times 5. So it is definitely a multiple of both of these numbers. And of course, the number we're talking about here is 150. So when you're trying to find the least common multiple, this is, I think, one of the easiest ways to do it. You find the prime factorizations, and then you look through and say, okay, what kind of, well, I'll go ahead and include the first number, and then I'll say what else do I need to throw in order for it to also be a multiple of this number.